Good afternoon, I'm Mr. Precella with my college algebra class, and I want to remind you all of functions. We were working with those the last time. Remember, our algebraic definition of function. It's an algebraic equation that assigns each number in one set called the domain to exactly one number in another set called the range. What we're going to be looking at today are piecewise functions and quadratic functions. Remember f of x, the function notation, that's just a fancy way of saying y. So, let me see. Here we are, piecewise and quadratic functions. We'll look first of all at piecewise functions.
Based on the name, those are functions that are broken up into pieces, and you'll see what we mean by that.
I'm going to say that a piecewise function is defined using two or more pieces. We're going to do two things with piecewise functions. We're going to evaluate them, and we're going to graph them. Evaluating them is pretty straightforward.
Are you writing down? Are you ready?
Mm-hmm. All right. Mm-hmm. So here's an example. What we're looking at right now is an example of what I mean by a piecewise function. In this case, it's broken into three distinct pieces. Let me write it down. This is number 2. Oh, it's h of x, not f of x. H of x equals, there are three pieces here. We'll use the piece negative 2x minus, is that an 18?
Mm-hmm.
For x values that are less than negative 7. We'll use the y value of 1 for x values between negative 7 and positive 1. This statement here in red, that inequality is a this thing is a compound inequality, and it's saying that your x values you're using are between negative 7 and positive 1. It's okay for x to equal negative 7, and it's also okay for x to equal positive 1. Notice there's that little equality bar on both of those. And what's the last piece? This would be my blue piece. X plus 9 is what we use to get the y value for x values greater than or equal. Oh, wait a minute. Oh, wow, I messed up.
On the red piece,
switch over.
There's not an equal sign
switch
right
over.
there. Okay.
You see where I put less than or equal to right there? There is no equal to possibility. The equal to possibility for 1 is down here on the blue piece. So let's scratch that out. Is that clear what I've done? I've scratched out that equal to. The only equal to possibility for 1 is the third piece. We know to use function notation. You take the x, you plug it into the function. Here you have to decide which piece you're going to use though. For example, I think they give us, 3 x values. They want us to find h of negative 9. Okay. H of negative 9. H of negative 4. Oh, it's 4 pieces. Good. H of 1 and H of 6.
Last time we said you take the number in the parentheses, plug it in for x.
There's an added wrinkle here. You have to figure out, you can't decide, I'm going to plug in negative 9 for every one of these x's, because then you're going to be getting 2 different y values. You can only get one y value. You have to decide which piece you're going to use. The x value is negative 9. The x value is -9. The number inside the parentheses is x. Is -9 less than -7? Is -9 between -7 and +1? Or is -9 greater than +1? I heard you say that -9 is less than -7. So we're going to use the green piece. That's -2. Replace the x with -9. Oh, this is going to work out nicely. -2 times -9 is 18 minus 18 gives me a y value of 0. Okay, h and -4. In this case, your x value is -4. Which piece are you going to use? Is -4 less than -7? Is -4 between -7 and 1? Or is -4 bigger than 1? It can only be one of them. The middle one. -4 is between -7 and +1. Hey, I look over here. There's no x to plug into. For the red piece, that piece is constant. Whatever x value you use, the y value is just a constant 1. Any questions on my logic there?
This little red piece is called a constant function. This is nothing to plug the x into.
Okay, the third piece, h of 1. In this case, x is 1. Which inequality allows x to be 1? Is 1 less than -7? Is 1 between -7 and +1? Notice there's no equality there. Or is it this one? 1 is greater than or equal to 1. Which inequality is satisfied by an x value of 1? And keep in mind, it can only be one piece. That last one, so it's the blue piece. We plug in the 1. 1 plus 9 is equal to 10. And finally, h of 6. The x value is 6. Which piece is satisfied by 6? Is 6 smaller than -7? Is 6 between -7 and +1? Or is 6 bigger than 1? Bigger than 1, so you use 6 plus 9 to get a y value of 15.
Why don't you go ahead and do h of 0, h of 10, and h of -10?
I'm going to, because these numbers, it's just floating in the order of the pieces are stated. That's unfortunate. Let's punch in these answers, though, just so that they know that
you're doing it right.
Yes.
Okay,
It gives
so
them peace of mind.
0,
1,
1, oops, 1,
10,
10,
and 15. No.
Oops, I got a click there.
Okay. So we're going to make up a few other examples, but any questions on those 4 answers? What if we had h of 0, h of
I said 10 and -10.
10, and h of -10? Let's start off with h of 0. We're still using that same function there, that 3-part function, I should say 3-piece function. X is 0. Which inequality is satisfied? Green, red, or blue? Is it? Is 0 less than -7? It's between -7 and +1. So what's the y value? If x is 0, the y value is 1. There's nothing to plug in. What about h of 10? Is 10 less than -7, between -7 and +1, or bigger than 1? So we're using that third piece. 10 plus 9 is equal to 19. What about h of -10? Is -10 less than -7? is negative 10 between negative 7 and positive 1, or is negative 10 bigger than 1? The first one, the green piece, negative 2 times negative 10 minus 18. That's a 20 minus 18, which gives me a y value of 2. Before you can plug in your x value, you have to decide which inequality is satisfied by the x value they're giving you. Any questions? And to decide, you have to look at the inequality and see which one's satisfied. Yes.
Is there ever a case where one of them could be in both?
If it were, though, you'd have the same x being assigned two different y values. Is that a function?
Remember, that's why you knew, oh, you messed up.
Okay.
So there's that equal
makes sense.
sign. Because if there'd been an equal sign there, then for 1,
You would have gotten a 1
1
and a 10.
Right. And
And these are functions.
Okay.
You can't have one x having two different y values.
Okay, that makes sense.
Mhm.
Any other questions there? Evaluating piecewise functions is pretty painless. Now, graphing piecewise functions. That's going to be a little more involved, and we're going to do some things you may disagree with at first, but I'll explain to you once we've done it. I'll explain why we're doing it.
Well,
Okay.
at least there are multiple choice.
Yes, for the
Okay.
piecewise functions, they're multiple choice. There's not a piecewise graphing tool built into this course. So this is number 6. Okay, now we're going on to graphing piecewise functions. Graphing piecewise functions. This is number 6. We're going to do several graphing problems. There are 3 pieces. F of x equals,
What colors are you going to use?
I'm going to use 3 different colors. Each piece will have a different color. 3 plus 2x
We're writing that.
will give me the y values if x is less than negative 4.
So if it's something like negative 5, negative 6, negative 7, negative 4.1.
We'll use negative 2x if our x values are between negative 4 and positive 5. And everything except for the red looks black to me on the camera. But I was thinking maybe purple will stand out better than blue. We'll use 2x if our x values are greater than 5. 3 plus 2x. Let's make sure I didn't miscopy this. That's the negative 2x. Okay, that's right. Okay, switch over.
Oh. Oops.
Okay. What we're going to do to graph piecewise functions is we're just going to plot points, but we're going to plot points intelligently. We're not just going to randomly start choosing x values to plug in to generate points. We're going to plot the points intelligently. Now, the green piece I'm going to draw using my green ink. The red piece I'll draw using my red ink. The purple piece I'll draw using my purple ink, okay? But y'all are doing all of this in one color. So my advice to you is to number the pieces. Piece 1, piece 2, and piece 3. I'll tell you how we're going to generate the ordered pairs. And once we've got the graph drawn, then I'll explain why we did what we did, okay? But we'll start off the green piece. This is piece number 1. We're going to plot points, as I said, but we're plotting them intelligently.
We're going to wind up with a graph that has 1 part's green, 1 part's red, 1 part's purple, and it's going to pass that vertical line test. No vertical line will be intersecting in more than 1 point. Because if it is, it's not a function, and we know it's a function because it says f of x equals.
Okay, to get your starting point, well, first of all, y equals 3 plus 2x. All these little different pieces, y equals 3 plus 2x, y equals negative 2x, y equals positive 2x. What are those graphs going to look like? They're going to be lines, okay? You're right, slanted lines. If you just said a line, that's all I was looking for. How many points do you need to draw a line? What's the minimum number of points you need to draw a line? 2, that's all I'm going to find. To get started, to find the starting point for the green piece, whatever, for lack of a better name, these numbers that appear within the inequalities, I'm going to call them cut points. I'm going to call them cut points because there's nothing else that, there's no other name to call them. And the way you label the cut points will be the same way that you label them on a number line when you're using the cut point method. We're going to take the negative 4. Whatever numbers you see in the inequality, you're going to have to plug into that piece. I see a negative 4. I'm going to have to plug that in. But wait a minute. Can x actually equal a negative 4? There's no horizontal equality there. So what we're going to do to indicate that we plugged in a number that we shouldn't have, we're going to label it with an open circle. So the starting point is going to have an open dot on the graph. Now we need another x value, one that's actually less than negative 4. Well, how about, I was about to say, how about 0? Can I use 0?
No.
No.
Numbers less than negative 4. What's to the left of negative 4 on the number line? Negative 4,
we could use
negative 5,
we could use negative 15, but I don't want to
6.
count 15 units to the left, okay? So negative 5, let's use negative 5. Now is negative 5 a cut point? Do you see it there in that green interval? No, I don't see a negative 5 written there. It satisfies the condition. That's what you're saying yes about. It satisfies that condition. So any number that you choose on your own has to satisfy that inequality, which means it's just a regular closed dot. The only open circle you're going to have on that green piece is at negative 4. Let's plug in negative 4. What are we going to get? We'll have a 3 plus 2 times negative 4. That's a 3 minus 8. What are we getting for our y value here? Negative 5. Well,
and that's just a coincidence that it's the same number that we chose to plug in.
That's an
I'm
ordered
afraid
pair.
they'll start looking like this.
Okay, now we're going to plug in negative 5. 3 plus 2 times negative 5. That's 3. What is that? Minus 10, which gives us a negative 7. There's my second ordered pair. I generally don't write on the backs of pages because the way it shows through from the previous pages work, but here I think I need to do that. Here's what I'm going to be plotting, and I'm going to draw the graph over here. I'm going to draw an XY grid. We're going to be going up pretty high and pretty low, so I'm going to make a big graph. When you're drawing your grid, make sure that any cut points are clearly labeled on the x-axis. Like I see 5. 5's one of the cut points that we're going to need to label, and negative 4. Make sure you label those on the x-axis. Now we have 2 ordered pairs we have to plot. Negative 4, negative 5. Oh, look at that. Look at that y-axis. I really drew a good vertical y-axis. Well, there, from this angle, it does look straight.
It doesn't looking straight on.
Oh, okay. Well,
looks very
so
wrong.
negative 4, negative 5. open circle. And then the second point we want, -5, -7. That's a plain closed dot. The graph starts at that cut point, -4, -5, the open circle. It goes towards that second point that we found. Is this interval x less than -4? Here's the x-axis. There's -4. The numbers less than -4 on the x-axis are going to the left. Does that interval stop? Is this no? So the left side of the graph can't stop. Just continues. The left side continues going. This is called an open ray. The end point is half of a line, basically, and the end point is an open circle. Now, you can have a closed ray. That's where it's half of a line, but the end point is a closed circle. This one, it's an open ray. We'll discuss why do we even plug in -4? Since x can't equal -4, why do we start off using -4? That's a sensible question. We'll discuss that once we're through drawing the entire graph. Now the second piece. Here's the second piece. Don't let me move the paper. Right there is where I need it, okay? So the second piece, it's the red piece. This will be table number 2. X and Y. Any number that appears within the inequality must be used as, must be plugged in to generate ordered pairs. This is nice. We need 2 points. I think we know what we have to plug in. You don't have any choice here. You have to plug in -4. What other number are you going to have to plug in for x? That other cut point, 5. Are these going to be open circles? No, because you're using the same rules you use for solution cut points. Equality is allowed, so these are just going to be regular closed dots. Let's plug in the -4 into the red piece. -2 times -4 gives us a +8. So we just generated our first ordered pair. -4, +8. What's the second y value going to be? We're plugging in the 5. -2 times 5. What are we going to get? -10. There's the second ordered pair. There. So we go to our graph. We locate -4, +8. Okay, now we're going up. Okay, so we go to -4, +8. 1, 2, 3, 4, 5, 6, 7, 8. Close dot. The second point, 5, -10, we go right 5, down 10. I should have numbered these increments so I don't have to keep counting over and over. 6, 7, 8, 9, there's -10. So 5, -10, right there.
It should be clear to you that the red graph has to be between -4 and +5.
Will there be arrowheads? If so, on which side? There will not be arrowheads. This interval doesn't keep going and going forever. It starts at -4, it stops at 5. So it is just a closed line segment. Both endpoints are closed circles. That middle piece does not keep going forever. It starts and stops. It starts at when x is -4. It stops when x is +5. Third and final piece. Okay, any questions before we go on? Once again, we'll discuss why we plugged in that -4. Well, look at this third piece, the purple piece. What do y'all think I'm going to start off with plugging in?
5.
I have to start off with 5. We'll discuss why in a moment. That's our starting point. Is it going to be an open circle or a closed circle? It's going to be an open circle because there's no equality. We're going to need another x value, a number greater than 5. Could I use 4? Could I use 0? No. What do you think I'll use? 6, yeah. I could use 50, but 2 times 50, that's 100. I sure don't want to count 100 units up there. So plug in 5 into the purple piece. 2 times 5 gives us 10, okay. Plugging in 6. 2 times 6 gives me, hey, I didn't ask y'all this. Is this ordered pair 6, 12, is that going to be an open circle? You said 5 was going to be open. What about 6, 12? Will that be open? Does 6 satisfy the condition? Is 6 bigger than 5? Yes, it is. So it's going to be a plain closed dot. Any number that you choose on your own, you can't choose a number that doesn't satisfy the inequality. So any numbers that you choose on your own, these secondary values, it has to be a plain closed dot. You can't have open circles floating all over your graph. The only place an open circle can occur is at the endpoints, at the cut points. And here we have an open circle at -4, -5. This one here, we're going to have an open circle at 5, 10. Here's 10. Oh,
you're going to have to lower it a little bit.
I know, I'm going to, but I have room down at the bottom to lower
The
it.
hole in the paper is a closed circle.
Pardon me?
The hole in the paper is a closed circle.
Yeah.
Yeah, you're right. Oops. Well, okay, so 6. Yeah, well, that happens. 6. I'm going to make 6, 12. It's right a little bit above that that hole in the paper. We start at our cut point. It goes to the right. Does this x greater than 5? Does that interval stop? No, it's going to keep going to the right. If you're going to have arrowheads, you can only have one arrowhead on the left, one arrowhead on the right. If you tried, let's suppose you tried to put arrowheads here. Suppose you continued that red line. Would this pass the vertical line test? These are functions. We know the functions. They're using the function notation. So you know it's a function. If you continued this, suppose you put red arrowheads, would it pass the vertical line test? I claim it would fail it because this red point and down here it intersect the green spot, the green rate as well. Any questions? Now I want to discuss why did I even, I think it's easiest to see when you're working with positive numbers. Why did I plug in that 5? I just said earlier that x can't equal 5 here, right? 5 isn't greater than 5. Why did I use the 5? The real number system is dense. Between any two real numbers, there are infinitely many other real numbers. I claim that on the x-axis, there are infinitely many other numbers that look like 5 to the naked eye, but they're actually greater than 5. For example, how about this number? 5.000001. Do y'all agree that that number is greater than 5? If I plugged that in, I'd get 10.000002. This ordered pair has to be included on this graph. If I told you, label that point, label 5.00001, comma, 10.00002. If I told you label that on the purple graph, to the naked eye, what would it look like? It would look like you were labeling 510. There are points that are right there that look like 510. These points are on the graph, but 510 itself isn't. We have the open circle there saying 510 may not be on the graph, but there are plenty of points right there that to the naked eye look like 510. And if you think, I said there are infinitely many, if you doubt me, just start sticking another zero. 5 points, stick another zero before you get to the 1. You can keep sticking in more and more zeros forever. So you're getting closer and closer to 5.
It's going to
The
look
naked
like
eye,
5.
it looks like it's 5, and the y coordinate looks like 10, but in reality, it's just slightly different. So that open circle, likewise here, this open green circle, it's saying -4, -5 isn't on the graph. But if you had plugged in -4.0000001, you'd get a number, you'd get an ordered pair that looks like -4, -5. It's on the graph, even though -4, -5 itself is not. Any questions?
Now, when we check our answers, they're multiple choice, but Pearson doesn't show the points that you choose. It'll show the cut points clearly. Okay?
Well, it'll show the points here, the starting and
points.
stopping, but
I
you
said the
don't
cut
choose
points.
those. It shows the cut points, but it doesn't show the
A dot
secondary
right there.
points because who knows, you might have chosen, someone else might have chosen -6. They don't show the secondary points. You'll only see the cut points and the lines themselves. Line segments and rays, I should say.
Okay.
So here we
let's
go.
see.
You know something.
I'm going to make it smaller.
I think so. Where is that?
What here? Okay.
There, that's better. I think.
Okay, so
Start blowing them up.
I'll start with B. It's definitely not B.
Right. Okay.
Is it C?
No. D.
D.
I suspect it must be A. That's
Why did I
what's on the
skip A?
over
Let's see. A. Do y'all see what I mean? It doesn't show the point -5, -7 out here. It doesn't show the point over here. Which one was it?
612.
612.
They may have used 714.
Yeah, they may have used 714
They don't
or
show
heck,
the secondary
1020.
points.
By the way they have it
Only
labeled.
the cut points.
Okay.
So select A.
Check answer. Wow, if you can follow what we've done there, you understand a lot about graphing. A lot of graph theory.
Any questions there? Let's back up to an easier one now, number 3. Nice. A 2-part function. This is let's do number 5 instead. We'll come back to that.
Okay, we'll do 5.
Let's do number 5, then we'll come back to number 3.
I'm going to blow it up so they don't see the answer choices.
Okay, so
No,
f of x this time. There are
Just
2
two
pieces.
F of x equals -2 if x is less than or equal to 2. F of x is -1 if x is greater than 2. Notice why there can't be an equal sign on both of those symbols. Because if there were, then
You'd have a y value of -2 and a y value of -1.
at 2,
You can't have
2 y values.
2 y values for x equals 2.
Okay, so
Here, how many? We'll have 2 different tables.
Right. Let me
We'll have 2 different tables. I'll make the first table the red table. This is table number 1.
The thing that's unusual about this is the fact that it's 2 what's called constant functions.
Notice there are no variables there in the rules. Okay, for the red piece, We don't have a choice. What's the first number we must plug in for x to get our starting point?
2.
You have to plug in 2.
That's the red cut point.
That's the
Gotta
red
plug in
cut
that.
point. Is that cut point going to be open or closed? Which one?
For the red
Can
one.
x equal 2? Is equality okay on the red piece? Yes, and so this one's going to be a closed one.
Down here, it'll be open when you get there.
Okay, we need an x value less than 2. Can I use 0? Yes, I can use 0 for this one. 0 is less than 2, so I can use 0. Now the secondary point, the one I chose myself, will it be an open or a closed point? I heard open. Secondary points that you choose yourself must always satisfy the inequality. 0 is less than 2. Is that a true statement? So secondary points that you choose on your own must always be closed dots.
You wouldn't be choosing a number that didn't satisfy.
You wouldn't want to say plug in 3 into the red piece because 3 isn't less than 2. This is actually very nice because what will the y values be in both cases? Negative 2.
That's why it's called a constant function. Notice the y values
are
don't
not
change.
changing. There's my 2 ordered pairs. At least these y values are going to be, I don't have to make such a big graph this time. I don't need to use the other side of the page. I'll just do it right here. And okay, there's 2. Clearly label 2 on the x-axis because that's where the red piece is going to change to the purple piece. So we start at 2, negative 2, a closed dot. Then we have 0, negative 2, another closed dot.
What sort of line are we going to have here? If you connect these 2 dots, is it going to be slanted? No, it's a horizontal line.
Constant functions have graphs that are horizontal lines. You start at this point. Does this interval x less than 2, does that ever stop? Does that ever stop? No, so the left side of the graph can't stop. If you're going to have arrowheads, you can only have an arrowhead on the left side and one on the right side. You can't have arrows appearing in the middle of the graph. It can only be at the leftmost and the rightmost. Now let's make our purple table. This is table number 2. What's the first number I must use for x? I have to use 2. It's a cut point. It appears within the inequality, but how will I label this cut point? Will it be an open circle or a closed circle? Open because there's no equality. So we're going to use an open circle there. Now we need another x value, one that satisfies the inequality. What do you want to use? 3. Okay, we'll use 3. Is that going to be an open circle? No. Any number you choose on your own has to be a regular closed dot. In both cases, the y coordinates are -1. There's no variable to plug into. This is nice. We're at 2, right 2. Oh, let me put on my parentheses. Here are the 2 points I'm labeling. Right 2, down 1. I have an open circle. Then I go over right 3, down 1, a closed dot. So I start at the cut point, I start going to the right. Does it stop? No, it doesn't. 2 horizontal rays. represent the graph.
And if you were looking at a graph and it said find f of 2, if you're just looking at the graph, well, is f of 2 going to be -1 or 2, or -2?
If they asked you to find, or if you needed to find, looking at the graph, f of 2, what's the y value when x is 2?
Is it -1 the answer, or is -2 the answer? -2,
Right.
the one
That's
with the
what that
dot.
little dot is.
Include. Remember,
Closed
closed dots mean include that point. Open means don't include this one. This little dot is really representing 2.00000001, comma, -1.
Mhm.
Oh, now let's look at that. Choices. I'll make it small again so we can see them all. Let's see. I'm just going to go straight through. Is this one it?
No.
No. Okay. A.
I think that's it.
Okay. Well, let's knock out the other ones. Oh,
Well,
wait. What's the difference between B and
The
C?
dots are reversed. That's
Mhm.
right.
Yeah.
So that's not it. And D, the pieces are reversed.
Oh,
That's
yeah,
not
that's
it.
not it.
So
It is
response B.
Any questions on that one?
Now let's go back to number
Number three.
3. Oh. Number 3, look at the red dots bleeding through the pages. So number 3, we want to graph it's another two-piece function. That's good. F of x equals, we'll use x minus 2 if x is less than or equal to 3, and 1 if x is greater than 3. X minus 2 if x is less than or equal to 3. How many tables will I have to make here? 2, because there are two pieces. Piece 1 and piece 2. Starting off at piece 1. Piece 1 is green. I don't know if you can tell the color there or not, but I'm using green ink on piece 1. I don't have a choice. What's the first number I must plug in for x? I have to plug in 3. That appears in the inequality. That's my cut point where the graph is going to change from the green piece to the blue piece. Will this cut point be labeled with an open circle or with a closed circle? Which one? Closed, because there's equality. We're going to need another x value, one that's bigger than 3. Y equals x minus 2 is just a line. We need 2 points. What do you think we'll use for the second point? Something easy to label. I could hear you. 4, wait, less than 3. Be careful. I'm going to use 0. I'm going to use 0. 0 is easy to spot. It's there at the intersection of the two axes. You could use 2 or 1. You'll still get the same graph at the end. Now the secondary point, is that going to be an open circle? The number that I just chose myself? No, that's always, the numbers you choose yourself are always regular closed dots. Plugging 3 into the green piece, what are we going to get? 3 minus 2 is 1, I agree. Plugging in 0. 0 minus 2 is, okay, 0 minus 2, I agree, is -2. Here's my XY grid that I'm drawing. Okay, so we go to 3, 1, right 3, up 1. I have a plain closed dot. Then my second order pair is 0, -2. So left, right, 0, down 2. There's my second dot. I start at the cut point, 3, 1. I go to the secondary point. Do I stop or do I keep going? Keep going, because x less than 3, the left side, the interval continues forever on the left, so the left side of the graph has to continue. Now, any questions there? Now the blue piece. What's the first number I must use for x? 3. It's a cut point. Will it be open or closed? It's going to be open. I need another x value bigger than 3. I need a x value bigger than 3. 4, okay. Now is this one going to be open or closed? Any number you choose yourself has to satisfy the inequality, so it's automatically a closed dot. Hey, this is nice. What are the y coordinates going to be? 1 in both cases, I agree. Something interesting is about to happen. We go to the ordered pair 3, 1, intending to put an open dot there, and what do we discover? You already have a closed dot. If you have an open dot and a closed dot occurring at the same spot, your graph has a closed dot. That open dot is saying 3, 1 isn't on the graph, but wait a minute, yes it is. 3, 1 is on the graph because of the green piece. So if you have an open and closed dot occurring at the same spot, closed dots take precedence. You have a closed dot on the graph. And then 4, 1, right 4, up 1, starts there. It starts at the cut point, 3, 1. It goes to the right. Does it stop? No? There. The reason I wanted to do this is it illustrates what happens if you have an open and a closed dot at the same spot. The open dot says, this point isn't on this graph, but the closed dot says, yes it is. It's on the graph because of the green piece. So, if you have an open and a closed dot occurring at the same spot, the graph has a closed dot. Any questions there? A, no, B, no, C, no, it better be D. Well, that's a miscopy of the problem. Is that it? Yes, it is. Look, notice they're incrementing in units of 2. The spot's D. Any questions there? Okay. Now I need to talk some. Need to do some writing. But any questions over piecewise functions before we go on? Okay. The second topic in this section is quadratic functions. We've actually already graphed quadratic functions before. We've graphed quadratic functions in that first section over graphing tools. A quadratic function is any function that's defined by a quadratic expression. If something is quadratic, what exponent has to appear in the expression? X squared, and there can't be a bigger exponent. We said a quadratic function will either be y equals or f of x equals ax squared plus bx plus c, where a doesn't equal 0, you've got to have an x squared for the equation to be quadratic. That's why I said a can't be 0. The graph of a quadratic function is a smooth U-shaped figure called a parabola, P-A-R-A-B-O-L-A. A parabola is a smooth U-shaped figure. It'll either open upward or downward. I remember using a 3-point quadratic tool to graph parabolas back several weeks ago using the 3-point quadratic graphing tool, and I said we're going to get a more advanced graphing tool come in a few weeks' time. We're at that point now. This graphing tool is going to work the same way that the absolute value graphing tool works. You'll have to find the low point on the graph and then one additional point. Now the low point on the graph, or the high point, is referred to as the vertex. When I'm looking at the equation, I can decide whether the parabola is going to be opening upward or downward. If it's going to open upward, the leading coefficient, the number in front of x squared, must be positive. If that coefficient on x squared, if the a value is negative, then you expect the u to open downward. So just by looking at the equation, let's say we're going to do, the first one we're going to do, I think it's number 9. This is the first one we're going to do? Yeah, okay. Do we expect the u to be opening up, or do we expect it to open down? Down, because that a value is going to be, is negative. There are two different approaches for determining the location of the vertex. One of them is completing the square. That's more complicated. So you have to complete the square to find, if someone's expanded a circle and you need to find a center and radius, you have to complete the square. But to determine the vertex, we're going to use something, I think it's quicker to use something called the vertex or axis formula. The vertex or axis formula is x equals, it's a fraction, negative b over 2a. Here's an easy way to remember this formula. It's the quadratic formula without all the messy stuff. Think about the quadratic formula. It's x equals negative b, and then there's that messy plus minus the square root of b squared minus 4ac there. You drop all that messy stuff all over 2a. So this axis formula, also the vertex formula, is the quadratic formula without the messy plus minus square root stuff. Now, what do I mean by the axis? These U-shapes are symmetric. Imagine drawing a vertical line passing through the vertex. If I could tear this piece of paper out and fold the paper down this dotted line I just drew. If I did that, the right-hand side should lie directly on top of the left-hand side. Well, with human error, that wouldn't happen, but using the vertex graphing tool, it would definitely happen. They take care of that symmetry very nicely. The axis It's just the imaginary vertical line that passes through the vertex. When a parabola is opening upward, the vertex is the lowest spot on the graph. That means the vertex is the lowest it's the lowest y value. The minimum y value occurs at the vertex. They're going to be asking you, where's the maximum y value and the minimum y value when you're working with some of the word problems in this assignment. And I'll tell you right now, the maximum and the minimum y values are going to occur at wherever the vertex occurs. If a parabola is opening upward, the vertex corresponds to the minimum y value. That means the smallest y value. If a parabola is opening downward, are there any points on this graph that have y values bigger than this y value right here? No, this is the tallest point. It has to have the maximum y value. So when you're looking for maximums and minimums, you'll have to determine the vertex, maximum y value. These graphs are getting sort of messy, but there's something else I need to mention. They're going to be asking for the domain and range of these functions. We know the domain. All quadratic functions have the same domain. All quadratic functions have domain. That's right. You remembered Dale?
Yes.
Yeah, okay. I remembered it, okay. Dale remembered quadratic functions. There's no fractions. There's no square roots. So what did we say there in the class the last time? If the function has no fractions, no square roots, unless you're told otherwise, assume the domain is all real numbers. So they'll be asking you for the domain of each quadratic function, all real numbers. Now for the range, it depends on whether the y value is a maximum or a minimum. In order to determine that, you're going to need to know the y coordinate of the vertex. So for the range, if the parabola is opening upward, I'll say opening. First of all, do y'all understand what I mean when I say opening upward? Are y'all clear why I say this is opening up? The opening side is at top, okay? We said the y coordinate, the y value of the vertex would be the minimum. Then every other y value on it has to be bigger. So for the range of a parabola opening upward, it's going to be the y coordinate of the vertex, comma. Do these things stop or do they keep going forever when they're opening upward? Do they keep getting bigger and bigger or do they stop? They keep getting bigger and bigger, so to positive infinity. What about the range of a parabola when it's opening downward? I'll say range opening downward. Oh, I'm running out of room. Can I shrink this in? No, I ain't gonna be able to shrink. You know, I'm gonna do a manual zoom out. There, okay. Move it up like that. Okay, range opening down. Okay, it's opening down. Are we going to have an infinity or a negative infinity? A negative infinity, so that has to go first in the order pair the interval notation representation, because you always go small to big. So it's negative infinity. And what is the maximum y value? Where is it stopping? It is the y coordinate of the vertex. Hopefully that range stuff will make more sense when we look at an actual graph in a moment. Any questions there? To graph the vertex, a parabola, I'm going to find the vertex, and then I'm going to find one additional point, and the graphing tool will take care of the symmetry. All you need is the vertex and one additional point. Let's see, I'm going to say, to graph a quadratic function, I should have said parabola, it's less writing. Here's the little table I'm going to use. I'll use the vertex formula, negative b over 2a. That'll give me the vertex. Hopefully I'll get a nice number when I use that formula, and I'll have to plug that in to get the y value. I'm going to need another number. Look over here. What's my favorite number to plug in? 0. If I were to use 0 here and here, what would I get for the y coordinate? Negative 140. I can guarantee you the grid they give you is not going to let you count down to a negative 140. So when you're choosing that next number, you're going to have to choose it on your own. Choose something close to the vertex. For example, if you use the vertex formula and it reduces to, say, 5, use something like 6 as the second number. So I'll say number close to vertex. You're going to use a number close to vertex. Once again, I'm not sure that this is actually helpful. Maybe we should have gone directly to this example. We want to graph the quadratic function f of x equals negative 4x squared minus 48x minus 140. So this is number 9. I think we're starting off with about the messiest graph. That's why we chose this as the first one. Okay, I want the vertex, axis, domain, and range. Let me make sure I didn't miscopy it. Okay. So, let's use our vertex formula. X equals negative b over 2a. B and a are just like with the quadratic formula. What's b? Negative 48. Watch those double negatives. Then we have a 2 times, what's a? Negative 4. Negative 48 becomes what? Positive 48. Positive 48 divided by, what's this denominator? Negative 8. Are we sure I didn't miscopy this problem? 48 divided by negative 8 gives me a negative 6. I'll make sure I didn't miscopy. Surely I did.
Somebody would have told you if you had. Oh, yeah. Negative 4x squared minus 48x minus 140.
Yeah, okay. So we have our little table of values now. We know what that little negative b over 2a is going to be. It's negative 6. That's what we're going to have to plug in for the vertex. We're going to need another number close to negative 6. What do you want to use? I've already shown them you can't use 0. Use something real close. How about negative 5? Or negative 7? Use something that's close. I'll use -5. Tony's plugging in the -6.
Notice,
X.
make sure you put the -6 squared in parentheses.
So we're getting -4 times -6 squared minus 48 times -6 minus 140. Despite all those messy numbers, I think it's working out pretty nicely.
4.
I think we're going to get a +4. Because that's what Tony says we get. Now I'm trusting.
Now let's plug in the negative
Now let's
5.
plug in the -5. Plugging in -5, what are we going to get for y?
That's going to be a -100 minus 48 times -5 minus 140. It's going to be 0. Yeah, 0. Okay.
Ah, works out nicely. That's 0, and this one was 4. You all agree with our calculations there? And normally I would say, okay, let's just do, for the rest of them, we'll graph using the graphing tool. But since this is the first one, I'll draw it by hand. Okay, I'll draw it by hand because I want to have something to point at in a moment.
Yep. You need more up.
Negative. Oh, I do. Ah. Okay, I'll come over. Move that calculator. I'll come over here. I need it. There. Okay. Okay, so at -6, we're up 4 units. 1, 2, 3, 4. At -5, we have a y value of 0. We had already said, since that thing is a -4, will it open up or down? Down. Do y'all see the downward motion? It starts here and it goes down. Now just sort of draw the mirror image on the other side. That's pretty good.
Now let's start typing in. It says, what's the vertex? That's the first thing I got to type
Just
in.
ignore this grid. Vertex.
Make sure you type an ordered pair, which means you've got to put
Axis.
the
Domain. Range. Okay. The vertex was the ordered pair, -6, 4. Switch over to my thing. We're going to write all this out before we draw the graph using the graphing tool. The axis. The axis.
yes, it is.
The axis, you don't need to. The axis is this little formula you got. X equals -6. Back when y'all graph lines, we said that a vertical line is in the form x equals a number. Well, x equals -6. The axis is that vertex formula. What did we say was true about the domain? All real numbers. We're going to fill that in at the very beginning. And now, the range. Does the vertex correspond to a maximum or a minimum? A maximum, that's the maximum y value. We have the maximum y value of 4. Are there any points on that graph that have y values bigger than 4? No, that's what we mean by the maximum y value. That's the biggest y value possible. So the arrowheads are down here, which says what? Negative infinity. You always put a parenthesis in front of a negative infinity. Up to, where does it stop? 4. What goes after the 4? A bracket. And before we go and type all this stuff in, look at what I was saying here. If it's opening down, you'll have a negative infinity. And what will this number be? It's the y-coordinate of the vertex. Where did you get that number 4? It was the y-coordinate of the vertex. So let's go back.
We're ready to type in the rest.
Yes.
Oh no, we got to graph it first. Okay, click to blow it up. Oh gosh.
Okay, here it is. The thing that looks like a parabola. Realize whether it's opening upward or downward, you're going to click the vertical parabola tool. Then it says plot the vertex. This is just like that absolute value tool. The first thing you must plot is the vertex and see how it's showing the coordinates there. So we want -6, 4. Oops. Oh, negative there. Is that it? Nope, I moved it. There. Click it. Now notice as we move,
Every possible parabola.
you're looking at every possible parabola that has -6, 4 as its vertex. The secondary point that we found, notice it says to plot another point. Well, the secondary point we plotted was -5, 0. So is that it?
Mm-hmm.
Save it. Check. Now they want us to type the axis. The axis, notice it says type an equation. You must type it in the form x equals. It's that x equals that makes that the equation of a vertical line. If you just type a 6, that's not a vertical line, that's a number. The domain, we know the domain without even looking at the graph. It's a quadratic function, no fractions, no radicals. No.
Negative. See, that's why I wanted them just to have a button that said parentheses, negative, infinity, comma, infinity, close parentheses. Then you wouldn't have made that mistake.
Parentheses, negative, infinity, comma, 4. And we're using a bracket because 4 is used as the y-coordinate. There it is. Any questions there? When you're choosing the secondary value to plug in, be sure to choose a number that's hard to read my writing, but when you're choosing that secondary, the first number you'll plug in will be the vertex, whatever that little formula gives you. The second number, choose a number close to the vertex to make sure that your secondary point fits on the grid they give you. Any questions there? Let's go back to number 8.
Yeah. Has nicer numbers. Oops. Oops. It's already. Oh, well, no, I guess it closed.
Yeah. Number 8.
Oh, just looking at the equation, you know whether it's opening up or down. That number in front of the x squared, is it positive or negative? Well, we assume it's a positive 1, don't we? I'll be quiet while y'all write down the problem.
5 is x squared minus 14x plus 40. Hey, it wrote f of x there, and I put a f. Does that change anything? Did I miscopy the problem?
You wrote y.
I mean, I wrote y. Does that change anything? Did I miscopy the problem? No, f of x and y are the same thing. First of all, look at the number in front of x squared. I don't see a coefficient there, so what do I assume is that number? 1, that's positive. So is it going to be, do we expect the graph to be opening upward or downward? Upward, I agree. Using our vertex formula, x equals minus b over 2a. What's b? What's the number in front of x? Negative 14. So watch out for those double negatives. What's a? So the opposite of negative 14 becomes positive 14 divided by 2 gives me 7. So the vertex is going to occur when x is equal to 7. We'll make our table of values. We have to plug in 7. Hey, do you think the second number, could I use a 0? Well, I guess I could, but do you think I'll be able to label that point? Because that's 40. That would give me a y value of 40. So as I said, choose a number that's close to the vertex. Don't move more than 2 units away, and then you'll always be okay. So what do y'all want to use as the secondary x value? 8. Okay, that sounds good. Plugging in 7. Where's that calculator of mine? I have to write small so the graph fits here because I can't decide to do it over here. We have plugging in 7. So we have 7 squared minus 14 times 7 plus 40. 49 minus 9. Negative 9. So there's my vertex. Let's make a note of that. This ordered pair is my vertex. That'll be the first point I plot in a moment. Now plug in 8. So we'll have 8 squared. Now some calculators don't have that little designated squaring button. You have to just use your little caret top and put a 2 there for 8 squared minus, or you can just remember 8 times 8 is 64 plus 40 equals, let's see, I wasn't expecting it to be so close. Let me see, 64 minus, did I write that, did I punch in the right
112 plus 40, that's right.
Yeah, so a negative 8. There's my secondary point. Come over here. Get rid of that calculator. They want the vertex. Let's write out the vertex first. There it is. I'm going to write out 4 blanks here. Vertex, axis, domain, and range. What's the vertex? 7, negative 9 from the first row of the table we created. So come over here, top the ordered pair.
Oh, right, what did I tell you?
You put a period.
Oh my gosh, it is a period, not a comma. Huh. Oh, wow.
Now we're ready to draw our graph. Let's just draw it on here. It looks better than what we can do on the paper. What do I click? The parabola tool there. And now, what's the first point of plot?
7,
7. Uh-oh, I moved it. Is that it?
yes.
Lick it before I move it. And then as you move your cursor, this thing is creating every possible parabola that has a vertex at 7, -9. We need an additional point. The additional point we got was 8, -8. Is that it? Save it. Check. The axis. Let's come back over here. Let's write in axis. It's the equation, that vertex formula. X equals 7. That's one of those things on tests. People will email me, oh, they messed up on the axis. Can they get credit? I look there. If I see a 7, what do? No, don't get any credit.
Got to be a line.
Well, you got, assuming you found the 7 correctly here, then you got credit there for finding the 7. But if you don't write it as x equals, then you're telling me you don't know that vertical lines are in the form x equals a number.
Not just a number.
And the domain, we know the domain. I could have written that in immediately, but they wouldn't let me. Type it in. So let's go back. We're typing in the axis. X equals -7. X equals 7.
I wanted to show them. If you just type a 7, they don't know. They just know it's wrong. Oh, well, they try to tell you the vertical line x equals minus b over 2a. So they are telling you, hinting that it's got to be x equals.
Would it say on the test to type in an equation?
It will say type an equation.
Mm-hmm.
So that's your clue.
Yes,
that's your
the
clue.
Mm-hmm. Negative infinity, comma infinity, close parentheses. Now we need to look
Let
at.
me ask you something. For this, the vertex, let's make it bigger.
And one
Is
more.
this y value corresponding to a maximum or a minimum? Is this the biggest y value on the graph or the smallest y value? It's a minimum. Okay, what's the smallest y value on that graph? -9. That's the y coordinate. Remember I said you'll use the y coordinate of the vertex when determining the range. Now when I look at this graph, is the range going to involve infinities or negative infinities? Infinity, that's the bigger number or the bigger concept. So I know infinity can't go first. There's never a time you're going to be writing parentheses, positive infinity, and something else. You know then the infinity has to go second, and the smallest y value is -9 with the bracket. Once again, go back to what I said earlier, what I was trying to say. When the range of a quadratic function, when the parabola is opening upward, you use the y coordinate of the vertex. That's where we got that -9, the y coordinate of the vertex, and then on to positive infinity. So hopefully these generalizations make a little more sense now that you've seen an actual graph. So let's go back and type in these answers. Oh, the only thing we have left is the range. So bracket -9, comma, infinity. And before you go on, y'all said that the vertex corresponded to what? A minimum. What's the minimum value of the function? Is it 7 or is it negative 9? What's the smallest y value on this graph? Negative 9. The value of the function is the y coordinate. It's not the 7 that you found. The value, the minimum value, is that y coordinate. We've done number 9. Here's number 10. The figure shows the graph of a quadratic function. Use it to find the minimum value of f of x. F of x is the same as what letter? Y. So what's the minimum? Well, do you agree that this corresponds to minimum? The parabola is opening upward. So the vertex is at the highest point or the lowest point? The lowest point, okay. So what's the minimum value of f of x? That's the minimum value of y. It's a positive 4, not the negative 4. The point of this is they're trying to point out that the value of the function is the y coordinate, not the x coordinate. Well, that's a pretty fast one. Any questions there? Okay, now some word problems.
Don't panic.
You're not going to.
They were telling me they were going to panic.
No, I did the wrong thing here. A woman is a taco stand. She found that her daily costs are approximated by C of x equals x squared minus 20x plus 670, where C of x is the cost in dollars to sell X units of tacos. I don't know if a unit is a single taco, maybe a unit is a dozen, it doesn't matter. Find the number of units of tacos she should sell to minimize her cost. And what is the minimum cost? First of all, make sure we understand what they're talking about. The cost, to us, the cost is what we're paying to buy the taco. But for the taco stand owner, her cost is the money she has to spend to run the taco stand. She has to go and buy supplies. Maybe she has to hire someone to help her. She has to pay rent. Those are her costs. That's what we're trying to find the minimum value of. Let's write down the cost function. This is number 11. Her cost function, her costs are given by x squared set of minus 20x plus 670. Okay.
X is the number of units of tacos.
So I'll make a note. C of x is the cost. And x is the number of units of tacos. Once again, I don't know if it's a single taco or...
And I'm not sure if minimizing cost is actually what someone would want to do in this business. If you're selling tacos, you're probably more interested in maximizing profit than minimizing cost.
Profit is what you have left over after you pay all your bills. Revenue is what you take in. The money that goes into that cash register, that's your revenue. But just because you take in, say, she takes in $2,000 that day, that doesn't mean all $2,000 goes in her pocket. She then has to go and spend the money to buy the supplies, pay the employee or employees, what have you. So the bottom line, the profit, is really the most important thing. And would you want to minimize the profit function? I don't think so. I think you'd want to maximize the profit function, okay? But if you're trying to reduce costs, maybe she's going to lay off some people. That's what she's going to do. So she's going to minimize her costs. I don't know. But either way, let's look at this function. They don't ask us to draw a graph of it. But if they did, do we expect the parabola to be opening upward or downward? What do you look at?
Upward.
Upward, because...
It's not a negative.
Okay, that's not a negative. It's a positive 1. So we expect the parabola to open upward. If the parabola is opening upward, here's the vertex. What do we have there, maximum or minimum? If a parabola is opening upward, we expect the vertex to correspond to a minimum. Is that what they ask us to find? Is that what the instructions said? It better be.
It wouldn't make sense. Who would, in their right mind, would ever want to maximize their costs?
But sure enough, they asked for a minimum. So, if it's someone trying to, drive the company out of business.
Well, yeah.
Okay.
So they're going to have their little quadratic function there, doing this.
The minimum value will occur at the vertex. We know how to find the vertex. We have our little vertex formula, x equals negative b over 2a. And what's b? Negative 20. So watch out those double negatives. What do we say a was?
1.
A positive 1. The opposite of negative 20 is a positive 20 divided by 2 times 1. So give us 10. Is that $10? Is that saying that her costs are going to be $10? What is X representing? Units of tacos. So that's saying if she wants to minimize your cost, she needs to
make and sell
10 units of tacos. So I'll write 10 units of tacos.
I think that's the first question it asked.
Do they ask for the actual number of tacos?
The number of units of tacos she should sell to minimize her cost is
10. I bet you now they want to know, what is that minimum cost? What is that minimum cost? Once you know the X value, how do you find the Y value? Switch over. Once you know the X value, how do you find the Y value? What are we going to have to do? Plug in the 10. So the cost, when you plug in a 10 for X, that's 10 squared minus 20 times 10 plus 670. I can do this in my head. That's 100 minus 200. That's a negative 100 plus 670. It looks like her minimum cost are $570. That's the lowest your cost will ever be. So if she's going to turn a profit, she better take in more than $570 at that cash register every day.
These 10 tacos.
10 units. I'm hoping a unit is like.
I think a unit is certainly not just one taco. If it's costing her $570 to make 10 tacos,
she'd have to sell those tacos at $57 each just to make a profit.
No, just to break even.
I mean, just to break even, just to cover her costs. So obviously, a unit of tacos is not just a single taco.
So 570. This function used to bother me.
Wait.
Because,
let's see.
Well, for these word problems, they're pretty straightforward. Minus b over 2a and plug it in.
Because they'll be asking for the maximum or the minimum.
Right, number 12. Oh, this is the rainfall.
The number of mosquitoes, M of X in millions, in a certain area depends on the June rainfall X in inches. The function that models that phenomenon is M of X equals 20X minus X squared. Find the amount of rainfall that will maximize the number of mosquitoes. And what is the maximum number of mosquitoes? Once again, I don't know if I buy this function either. Are you telling me that I always thought the more rain there was in hot weather, the more mosquitoes? Is that how it works? But apparently there's a maximum. Maybe after a certain point, the mosquitoes start drowning? You think that?
Yeah, I would think that there's some point at which, okay.
Okay, well, I'll write it down.
Write down the formula. M of X equals 20X minus X squared.
Tell me.
And there's something wrong with this function.
Okay, M of X is the number of I'm just going to write mosquitoes out of brevity, since it's almost spring break, and I know y'all want to mosquitoes.
And X is inches
I
of
left
rain.
off an E, didn't I? And X is inches of rain.
It says right here, June rainfall X in inches.
there's something odd about this function. I see that it has an x squared, so it's definitely a parabola. If we were going to graph it, would we expect this parabola to open up or open down? Which one? Downward. What's the leading coefficient? That -1 right there. Just because the x term is first doesn't change that the a value is negative. A is the number in front of x squared. That a value is a -1. So we expect the parabola to open downward. If it opens downward, what do you have, a maximum or a minimum? A maximum? What do they ask us for? The maximum or the minimum? What are we looking for? It better be a maximum. Is that it? What does it say? Maximum, you're right. So we're looking for a maximum, and we know the maximum is going to occur right here. What's that point called? The vertex. So we have to use our vertex formula. X equals -b/2a.
You know what, they might like it better if they actually wrote -x² plus 20x.
I don't think so. It's easier to punch it into a calculator. I'm assuming y'all are using a calculator to plug the number in. I think it's easier to use it in this form here. Okay, what's b? Well, it's just 20, but we have that negative sign there, so we have a -20. And what did y'all say a was? -1. Be careful. What's that going to give us? Okay, -20 divided by -2 gives us a +10. Suppose we'd gotten a -10. Would that be okay? What is this 10 representing? X is inches of rain. Would it make sense to get -10 inches of rain?
Just like earlier in the other one, it wouldn't have made sense to have a negative number of units of tacos.
I should have mentioned that. You're right. It would not have made sense. So it looks like
10.
Okay, so the number of mosquitoes will be maximized when there's 10 inches of rain. How do we find the value of the function? How do we find the actual number of mosquitoes? What are we going to have to do with that 10? Once you know the x coordinate of the vertex, what do you do to find the y? Plug it in. So we're plugging in 10 for x. That's 20 times 10. This is another one I can do in my head, Tony. That's 200 minus 100. It looks like there's 100 million mosquitoes. So when there's 10 inches of rain in June, we have 100 million mosquitoes in wherever this fictitious country is.
And could you ever have 200 million mosquitoes?
Yeah. Will there ever be 200 million mosquitoes during June? No, this is the largest number of mosquitoes that area can ever have.
So type in the 100. Any questions? One more minus b/2a.
Let's see. If an object is projected upward from the ground, from ground level with an initial velocity of 96 feet per second, then its height in feet after t seconds is given by s of t equals -16t squared plus 96t. Hey, we're not using x. What variable is taking the place of x? T. So instead of, when using the vertex formula, instead of x equals minus b/2a, it's going to be what equals minus b/2a? What letter will we have for minus b/2a? It's not going to be x. It's going to be t. If we were to find the number of seconds it will take to reach a maximum height, what is that maximum height? Wait a minute. Let's verify that we actually have a maximum. So y'all said t is acting like x. What's the a value? -16. So is this parabola going to open upward or downward? Down, okay. If it opens down, do we have a maximum or a minimum? a maximum. And where does that maximum occur? What's it called? Starts with a V, the vertex. So we're going to use our vertex formula, not x equals, we'll use t equals minus b over 2a.
So using t for time.
And that's standard practice in a physics environment. So what's b? What's numbers going to go here? What's b?
96.
96.
They just want you to finish the problem so they can get out.
And we've already said a is negative 16. So that is a negative 96 divided by, what's the denominator? 2 times negative 16 is a negative 32. And negative 96 divided by negative 32 gives me a 3. And is that feet or what? What is t representing? Time, so that's 3 seconds. The object goes up in the air for 3 seconds. It reaches a high point, and then what does it do? It falls back down. So, do they ask for the time it takes?
I think so.
It takes this object, it goes up for 3 seconds. And now we want to know the actual height. How high did that object go? Once we know the first coordinate of the vertex, what do we do to find the value of the function? Plug it in. So the height after 3 seconds, that's negative 16 times 3 squared plus 96 times 3. That's going to give me a 288. 140, that's a 288. This is a negative 144, so a positive 144. Are you punching it in? 144? So was it feet or meters or what?
Feet.
Feet. So that object, oh yeah, we're in America, right. So we got to use
The
feet.
negative 16.
Oh, you're right. The
Yeah,
negative
that's like
16, it has to be in terms of feet. That negative 16 is due to the acceleration due to gravity, 16 feet per second per second. 32 feet per second, I'm sorry. 32 feet. Any questions there? Okay.
So, if you've gotten behind, well,
This-
first of all, for spring break, the number one thing you have to do, go home, clear the fields, and plant the crops.
That's the purpose.
That's
Back
the
in the
purpose of
olden
their
days,
spring break, okay?
all the major
Plant the-
universities in the, were in rural areas. The people had to go home and help their parents. Well, the ones people say they're in the city, they got to go home. Those students were from the farms. They had to go plant those crops. So
So you do that. Then once you're through planting those crops, you catch up on your math. Then, after that,
you can have fun.
yeah. Well, I mean, if you're behind in your English and history and everything else, okay.
Oh, well, you got
that.
to do that too. Okay.
But main thing is math.